Let me get your attention, please. Here we go. 4, y minus 2 squared equals 8 times x plus 3. Identify the vertex, the focus, the axis of symmetry in directrix. Then we'll graph the parabola. And I always think of y equals x squared when I do these. I know that that opens up. I've known that for a long time, and hopefully you have too. So I think every time x is squared, it opens up or down. Every time y is squared by process of elimination, that's right or left. So we have our parabola opens either right or left. We know the vertex right away because it's in what we call standard form. I like to think of this as vertex form. But the vertex is negative 3, 2. You always got to think opposite. Not only do you think opposite, you keep the x with the x and the y with the y. So that's why it's not 2, negative 3. You don't want y in the x position and so on. So to do this problem, I just graph it and answer as we go along. So let's plot negative 3, 2. Right there. Well, this is in the form y minus k squared is equal to 4p times x minus h. So the h goes there, and the k goes there. So we have the vertex. But in this equation, p is the distance from vertex to focus. 4p is equal to, in our case right here, 8. So p is 2. The distance from the vertex to the focus is 2 units. Now because y is being squared, that means this opens to the right. So the focus is over here at negative 1, 2. Focus, negative 1, 2. The directrix now is on the other side of the vertex. So if the focus is on the right of the vertex, the directrix now will be on the left of the vertex. That line is the equation x equals 1, 2, 3, 4, 5. So the directrix is x equals negative 5. So I have the vertex, I have the focus, I have the directrix, axis of symmetry. That cuts the parabola in half. That's going that way. We usually don't graph that. But there's your axis of symmetry. It's the line y equals 2. I think I have all the information now I need to graph it. We have this thing called the lattice rectum. Now that is equal to the absolute value of 4p, which means we don't want to ever report this as a negative value because it's a length. It's the length through the focus, parallel to the directrix. So in our case, it's 8. Right there, it's just the 4p. Now we go over to the focus, and since the length of the lattice rectum has to be 8, we go 4 up, 1, 2, 3, 4, 4 up, and 1, 2, 3, 4 down. And what's really nice about this is it's a very easy way to get 2 points on the parabola. So the parabola goes through these 2 points. Then we just kind of draw a nice smooth curve, and that's all I'll require. I suppose some teachers, when they teach this, are like, all right, get those 2 points. I'll get 2 more points, and 3's fine if you know it's a parabola. As long as you know the basic shape, you'll be fine. That'll be a pretty accurate graph. Now, I want to talk a little bit about why do we have this directrix? What is this all about? Well, a parabola is the set of points. Well, a circle is the set of points equidistant from a point. So that's where you get that circle, right? They're all the same distance from that one point. Well, a parabola, if you pick any point on the parabola, that should be the same distance from the vertex, the focus, as it is to the directrix. So see how both of those are 4 units long? Now, if I pick any point on the parabola, that should be true. So if I pick a point way out here, the distance from focus to this point should be the same as this one to the directrix. That should be the same distance if I drew a perfect parabola. So in general, that's what we want. So as long as you get those 3 points and kind of draw a smooth curve, we'll call it good. Even though when we get down here, we might be a little bit off. That's not a big deal. Write x squared plus 4x plus 4y equals 4 in standard form. I like to think of it as vertex form, but that's all right. We have x squared plus 4x plus something equals negative 4y plus 4, and plus something. We're going to complete the square. I want to make this equation look like that equation right there. Well, that's completing the square. That's y minus 2 times y minus 2. So we take 4, we divide it by 2, and we square it. That's 2 squared, that's 4. Well, in Nebraska, you have to add something to both sides of the equation. You can't just pick one side. Illegal in Nebraska, right? Okay, cool. I've never taught in Iowa. I don't know what they do over there. X plus 2 times x plus 2, that's what that factors into. Over here is negative 4y plus 8. Well, we're getting close. We have to get that coefficient right there. We got to get that to be a 1. And we're going to do that by factoring out a negative 4. X plus 2 squared equals negative 4 times y minus 2. Now we have our vertex. Vertex is negative 2, 2. Keep x with x, keep y with y. Don't mix the two up. Let's start plotting. Negative 2, 2, right there. 4p is equal to negative 4, so p is negative 1. That means this thing opens down or opens to the left. And because x is squared, that means it opens down. So the focus is 1 unit away from the vertex, down. So there's our focus, negative 2, 1. Vertex, focus. Axis of symmetry is x equals negative 2. It's a line. It's not a point, it's a line, so x equals. And then the directrix, that's part of graphing it, is, well, if the focus is 1 down, the directrix is 1 up. Right there, that's the line y equals 3. Then graph the parabola. So the lattice rectum is, it's 4, it's absolute value. It's a distance, so it's never negative. That means through the focus, we're going to go 2 to the right, 2 to the left. And then we're just going to kind of draw a nice smooth curve like that. We'll call that good. Any questions? Very straightforward today, I think, with the exception of maybe completing the square. But we're going to have to do a lot of that in conics.